asked this past paper question. This question is a very interesting question and you can learn a lot of things from this, even though it's an old question. It came in 1997. So let's read the question first. A metallic vessel containing a certain amount of water is heated uniformly at a constant rate. So this is the vessel, this is water. Now, please underline that. If the heat loss to the surroundings is neglected, no need to underline that. This one is very important. Then the rate of absorption of heat absorbed by the vessel. So here the question is about the vessel only. Okay, the rate of absorption of heat by the vessel when plotted against time is best represented by. So there are 5 options. Now you can pause the video to find the correct answer. Okay, now I'm going to explain. So let's check whether your answer is correct. So now the heat supply, the rate of heat supply, which is denoted by P, which is power, to the system is constant. So you're giving constant amount of heat. So it will create an increase in the temperature of the system, which means both components, water and the vessel. So they will absorb some heat to increase their temperatures. Because these two are in contact, they will be in thermal equilibrium. So the temperature rises equally in the vessel and in the water. So therefore, I can say that according to their specific heat capacity and masses, to attain an equal amount of increase in the temperatures, they will divide the heat between themselves. So according to their mass and the specific heat capacities, this will get one portion of the total heat supplied and the vessel will get one portion of the total heat supplied. So do you understand that? Okay, now let's try to write an equation. So now this is the power supply to the whole system. This is the power gained by water. This is the power gained by the vessel. So instead of power, I'm going to substitute it with MC theta divided by time. Okay, so look at this. So power, total power is equal to MC theta for water, MW, CW, delta theta, is the temperature difference, divided by time to convert this energy to power, plus M vessel, C vessel, delta theta divided by time. Okay, so now you can understand that the power supply is constant. So therefore, here the MWCW is a constant, MVCV is a constant. So therefore, they will have a uniform rise in the temperatures. Okay, so this delta theta by time is also equal, and that is also a constant value for this system. So now the question is the rate of absorption of heat by the vessel. So rate of absorption of the heat by the vessel is given by this component of this equation. Okay guys, so it's not the total heat that we supply. Okay, let's say the power given with time varies like this, constant. Now a proportion of it will be gained by, will be for this vessel. So I write the power vessel per time, which is the question here, a proportion of it. If this one is some value P, this one will be less than P. Okay, so that's the PV at the initial stages. Now both of the temperatures will increase, so one part will go to this, one part will go to this, and it will be a constant. So after some time, I have to stop and think, will it be constant? No, because there is water inside it. At 100 degrees Celsius, up to 100, the water will have rise in the temperature, and after 100 degrees Celsius, the water will undergo vaporization, which means vaporization at boiling point, which is boiling. So there is going to be latent heat absorbed by the water. So in this stage, due to the change of state, the temperature of water will remain constant for some time. So in that instance, the heat given will only be absorbed by water. Why is that? Because the temperature of vessel is also constant during the time period of boiling. So therefore, this delta theta will be 0 for vessel. So understand, during the boiling, the rate of heat energy absorbed by the vessel will be 0, because the temperature difference that's happening, temperature increase that's happening during the time period will be 0. Delta theta will be 0. So now PV will become 0 and it will remain 0 for some time until the boiling finishes. So what happens to the heat given? It's totally used to break the bonds in water. So if you can to understand it better, you can actually plot a graph for water also. So initially water will have some proportion of the heat supply, okay, until 100 degrees Celsius. Now the sum of this one and this one will be equal to this one. Do you understand? Because they divided initially, but after some time when this one undergoes boiling, this will get all the heat. So if this is P, now this will get the total P, get the P totally. Okay, so it will get the P totally. And after that what happens is, after boiling there is no water. So now there is no component known as water, so the graph ends here. Okay, so I will continue this because for this one I have drawn up to this now. So I will continue this up to this and the graph ends for water here. Then after that what happens? The heat is still being supplied, so therefore that will be totally received by one and only component of the system, which is the vessel. Okay, so now the vessel will receive the total heat supply, so therefore it will be like this. It will go on until this starts melting, and then maybe it can boil. So anything can happen, but this is the graph. This is the graph for the variation of power absorbed by, rate of power absorbed by the vessel with time. So the correct answer will be the fourth answer. Thank you.